Okay, so in this worksheet, you're simplifying these expressions, and you want to write each answer, each result with positive exponents. You don't want any negative exponents in your answers. Okay, so in number 1, you don't have any parentheses, so it doesn't look like number 8, for example. There are no parentheses, so this one's fairly easy to deal with, easier than the others. They're all not difficult, but you do have to remember your rules. Okay, so I would deal with the coefficients first, and so basically we have this. We have 8 and negative 16. Now, I can reduce 8 to negative 16, and I'm going to go ahead and use the greatest common factor. And so the greatest common factor of 8 and negative 16 is 8. So 8 goes into 8 one time, and 8 goes into negative 16 a negative 2 times. Okay? All right, now, for the variables, you'll notice that I have x's in both numerator and the denominator, so I'm going to use the quotient rule. So at this point, I have this. I have 1 divided by negative 1/2 is negative 1/2, and then I have x to the, and remember in the quotient rule, you divide when you divide bases, you're going to use the quotient rule. So when using quotient rule, you subtract exponents. So this exponent is 1, this exponent is 1, so I get 1 minus 1. And over here, I get y, and then again, you do quotient rule, dividing like bases, you subtract exponents, so I get 2 minus 5. And so when I simplify this, I get negative 1/2 times x to the 0 power times y to the negative 3rd power. Okay? All right, now let's simplify each of these. Okay, so this part right here, x to the 0 power, remember any non-zero number raised to the 0 power is 1. So that's that 0 exponent rule. And so I get negative 1/2 times 1 times, and this right here is 1 over y to the 3rd. So remember, you had to make this exponent positive. So you're using the negative exponent rule. And so now you're going to write it as one fraction. Do not leave your answer like this. You have to write it as one expression, one fraction. So I get negative 1 times, and remember this is 1 over 1, so negative 1 times 1 times 1, which is negative 1. 2 times 1 times y cubed is 2y cubed. Okay, so that's the answer to number 1. Okay, number 2. All right, number 2, so this is negative 1 over 2y cubed. All right, number 2, you have 6x cubed y to the negative 5th squared. All right, so 6x cubed y to the negative 5th squared. Okay, so you're going to use the power of a product rule. So remember the power of a product rule. And so when I use the power, remember this power of a product rule. All right, and so basically you're going to take each of these factors and you're going to raise it to that factor, to that exponent, to that power. So basically you get 6 squared times x cubed squared times y to negative 5th squared. So that's what you have in your mind. Now you don't have to write this down, but this is what you're thinking about. This is your thought process. And so now I'm going to use the power rule now. The power rule. All right, so 6 to the 1st squared is 6 squared. That's 36. So the coefficient is not that difficult to deal with. 6 squared is 36. 6 squared means 6 times 6. Here, when using a power rule, remember when you have an exponent, when you have a power raised to power, you multiply these exponents. So 3 times 2 is 6, and it becomes 8 to the 6th power. And then here, again, power rule, you multiply, you have a power raised to power, you multiply exponents. So that's y to the negative 10th. All right, now remember, you don't want any negative exponents, so you got to rewrite this part here. So this becomes 36 times x to the 6th, and then y to the negative 10th, remember, is 1 over y to the 10th. And so now you're going to write as one fraction. Don't leave it like this. So you're going to say 36 x to the 6th divided by y to the 10th. All right, so that's your answer there. All right, so 36 x to the 6th times y to the 10th. So that's the answer for this one. So we're going to say that's 36 x to the 6th divided by y to the 10th. All right, number 3. Okay, so let's look at number 3. So this is what you have for number 3. Number 3, you have a to the 4th, b to the negative 6, raised to the third power. So it's kind of like we did number 2. So you're going to use the power of a product rule here. So the power of a product. So basically you're going to take each of these factors and you're going to raise it to the third power. So basically you say a to the 4th cubed times b to the negative 6 cubed. And then you're using the power rule. So when you have a power raised to the power, you multiply. So that becomes a to the 12th power times b to the negative 18th power. Negative 6 times 3 is negative 18, the power rule. And again, you don't want any negative exponents, so you're going to rewrite this part here as a positive exponent. So remember, right now it's in the numerator, so it's going to end up being in the denominator. But remember, the negative exponent rule says this: a to the negative b is 1 over a to the b power. So that's the negative exponent rule. All right, so this becomes a to the 12th times times 1 over b to the 18th. Now when you write it as one fraction, remember a to the 12th is a to the 12th over 1. So a to the 12th times 1 is a to the 12th. 1 times b to the 18th is b to the 18th. Okay, number 4. Okay, so that's going to be, this right here is going to be a to the 12th divided by b to the 18th. Okay, number 4, this is what you have for number 4. You have a to the 4th, b to negative 6, all raised to the negative 3rd power. So again, you're using the power of product rule first. And so you're going to end up getting, oops, that's the one we just did, didn't we? Oops, no, I'm sorry. So the difference between 3 and 4, so notice the difference between 3 and 4 is that the outer exponent is 3 here, and the outer exponent is negative 3 here. So just see, let's kind of see what the answer would be. So I get a to the 4th to the negative 3rd times b to the negative 6 to the negative 3rd. And so now I'm going to use the power rule in both of these. So a to the 4th raised to negative 3rd, so you're going to say 4 times negative 3. So when you have a power raised to power, you multiply exponents. So that's a to the negative 12th times b to the, and then negative 6 times negative 3 is 18. And notice the only difference is that here, the exponent of a was positive, and here the exponent of a is negative. And here, exponent of b is negative, and here exponent of b is positive. So just using the negative exponent rule here with this one, I get a to the negative 12 is 1 over a to the 12th times b to the 18th. And so remember, that's b to the 18th over 1, so you multiply the numerators together. So that's b to the 18th divided by, and then a to the 12th. Okay? All right, so that's number 4. So number 4, the answer should be b to the 18th divided by a to the 12th. Okay, number 5. All right, so number 5, you have this. All right, number 5. You have x to the negative 4th, y to the 5th, divided by x to the 6th, y to the 8th, all raised to the negative 2nd power. All right, now you can do this in a couple of ways. The path you take can start in 2 different ways. So let's just do this path first. So here, if you notice, this is a quotient right here. So I'm taking the power of a quotient this time. So when I do the power of a quotient, notice I'm saying power of a quotient. So the power of a quotient rule. So basically, you're gonna say, well, I'm going to take the power of the numerator. So that's x negative 4th. Oops. All right, let me do this right here. So x to the negative 4th, y to the 5th, all raised to the negative 2nd power, divided by, and then the denominator raised to that power. So x to the 6th, y to the 8th, all raised to the negative 2nd power. All right, so then now this kind of looks like the previous problem. So that's a power of a product. So now I'm doing the power of a product. Okay, the power of a product. So the power of product then says, well, I'm going to write this as, I'm taking each of these factors, I'm going to raise it to that outer exponent. So that's x to the negative 4th, raised to the negative 2nd, times y to the 5th, raised to the negative 2nd. Divided by, same thing here. X to the 6th, raised to the negative 2nd, y to the 8th, raised to the negative 2nd. And so now you use a power rule. So power raised to power, you multiply exponents. So negative 4 times negative 2 is 8. So I get x to the 8th, y to the 5 times negative 2 is negative 10. 6 times negative 2 is negative 12, so I say x is negative 12. And then 8 times negative 2 is negative 16, so y to negative 16. All right, so that's where I'm at. Okay, so now I'm going to use the quotient rule. The quotient rule. So when you divide like bases, you subtract exponents. Divide like bases, subtract exponents. So basically you're saying this. You're saying x to the exponents in the numerator, so that's 8. Subtract the exponent that's in the denominator. Times y to the exponent of the numerator, subtract the exponent in the denominator. So that's 8 subtract negative 12, negative 10 subtract negative 16. Now remember though, 8 subtract negative 12 means 8 plus 12. So remember, 8 subtract negative 12, you change this to an addition problem, so you add the opposite. So that's 8 plus 12. So this becomes x to the 20th power. And then here, negative 10 subtract negative 16, rewrite the subtraction as an addition problem, so you add the opposite. So that's negative 10 plus 16, which is 6. So that becomes y to the 6th power. No negative exponents, so you're done. So that's the answer to number 5. So number 5, you should get x to the 20th. X to the 20th times y to the 6th. All right, now the other way you could have done this, the other path, I'm going to go ahead and rewrite this problem again. So you could have done this, x to the negative 4, y to the 5th, divided by x to the 6th, y to the 8th, all raised to the negative 2nd power. So what you could have done first was just, if I had covered this, then you would kind of use the quotient rule here. So let's use the quotient rule here and see what happens. So if I go directly to the quotient rule, this becomes, remember, divide like bases, subtract exponents. So this, and remember, all this is being raised to the negative 2nd power. So that becomes x to the negative 4, subtract 6, times y to the 5th, subtract 8. Okay? Negative 4 subtract 6, 5 subtract 8. Negative 4 subtract a positive 6 is a negative 10. 5 subtract 8 is a negative 3, all raised to the negative 2nd power. And now I'm going to use the power of a product. Power of a product. And so you're going to say x to the negative 10 raised to negative 2nd power times y to negative 3rd raised to negative 2nd power. And now I'm going to use the power rule. When you have a exponent raised to another exponent, so you multiply those exponents. So this becomes x to the 20th, because negative 10 times a negative 2 is a positive 20. Negative 3 times a negative 2 is a positive 6. You get the same answer. So it doesn't matter which path you take. Notice that this particular path has a little bit more work to it than this path. Okay? But it's a good idea to know both scenarios. Okay, number 6. Number 6. All right, number 6, you have this. You have the same thing, same kind of idea. R to negative 5th, s to negative 4, divided by r to negative 3rd, s to negative 4, all raised to the negative 6th power. So again, it doesn't matter. Remember those two paths? It does not matter which one you take. If you take the power of a quotient first, then this is what you have to say. So you take the numerator, raise it to the negative 6th power, then take the denominator, raise to the negative 6th power. So that was using the power of a quotient first. Then you're going to take the power of a product on both the numerator and the denominator. So power of a product is next. So you're going to say r to the negative 5th raised to negative 6th power times s to negative 4 raised to negative 6th power, divided by r to negative 3rd raised to negative 6th power times r to negative 4, s to negative 4 raised to negative 6th power. And now you're going to use the power rule as next. The power rule. And so again, when you have a power raised to power, you multiply those exponents. So this becomes the numerator, that becomes r to the negative 5 times negative 6 is a positive 30, times s, a negative 4 times a negative 6 is a positive 24, divided by Negative 3 times negative 6 is a positive 18. And then negative 4 times a negative 6 is a positive 24. Okay, now, all right, let me make sure I wrote number 6 correct. Yeah, all right. So now we're going to use the quotient rule. Okay, the quotient rule. So when you divide like bases, subtract the exponents. That becomes r to the 30th, subtract 18, times s to the 24th, subtract 24. 30 subtract 18 is, what's that, 12? And then 24 subtract 24 is 0. All right, now don't leave your answer like this, because you got to remember you have to use your rules that you learned. One of the rules you learned is the zero exponent rule. So when you have a non-zero number raised to the 0 power, that is 1. And r to the 12 times 1 is r to the 12. So that's your answer there. So 6 is going to be r to the 12. Number 6 right here, r to the 12. All right, and then the other path you could have taken, remember, is by using the quotient rule first. So if you use the quotient rule first, so let's go ahead and do that. R to negative 5th, s negative 4, divided by r to negative 3rd, s negative 4, all raised to negative 6 power. So if we use the quotient rule first, then I'm going to get over here, that's going to be r to negative 5th, subtract the negative 3, negative 5, subtract negative 3, times r to negative 4, subtract the negative 4, all raised to negative 6 power. Over here, negative 5, subtract negative 3, negative 5, subtract negative 3, remember, change this to an addition problem. So you're going to add the opposite. So that's negative 5 plus the opposite of a negative 3 is a positive 3, and negative 5 plus 3 is a negative 2. So that's supposed to be an S right here. Sorry, that's an S. Okay, so that's negative 2. So this becomes r to negative 2nd power. Here, negative 4, subtract the negative 4, change this to addition problem. So you add the opposite, negative 4 plus, and the opposite of negative 4 is a positive 4, and negative 4 plus 4 is 0. So that becomes s to the 0 power, all raised to negative 6. Now there are a couple of ways you could deal with this. You can say 0 times negative 6 is 0, or you can automatically say s to the 0 power is 1. Okay? Does not matter. I'm going to go ahead and kind of just to be consistent, I'm going to do the power of the power of a product. So it becomes r to negative 2nd raised to negative 6 power times s to the 0 raised to negative 6 power. And so a negative 2 times a negative 6 is positive 12. 0 times negative 6 is 0. And notice that this right here looks like this. And remember, this right here is 1. So it becomes r to the 12th times 1, which is r to the 12th. Now I just want to say this, just in case you thought about this. See this right here, where I had r to negative 2nd times s to the 0? Some of you may remember, some of you may at this point have said, well, that is a 1 right here. And that's true. That is a 1. S to the 0 power is 1. So then you may get a little confused as, well, what do I do next? Well, it's not that difficult. This is what you would do next. You would say r to negative 2nd raised to negative 6 power times 1 raised to negative 6 power. And then here, you're going to use the power rule. So negative 2 times negative 6 is 12. Here, you're going to use the fact that 1 raised to any power, whether it's negative, positive, or 0, is always going to be 1. And that's what this is right here, r to the 12 times 1. And so r to the 12 times 1 is just r to the 12. Okay, so again, you can do different paths here, so notice the different paths you could take and get the same answer. It's a good idea to know all the different scenarios. Number 7. All right, number 7, you have this. Number 7, you have, this time you have in parentheses, you have a squared b to the 3rd power. And then in the denominator, you have a cubed b to the negative 4. All right, so here, what I'm going to do first, see this kind of looks different than this. See here, I had a quotient all raised to the negative power. here, the numerator and the denominator both being raised to different powers. So it's a little bit different where you start. So here, the clear path is that you would have to take the power product first on both of these. So we're doing the power product. And so in the numerator, using the power product, it basically says I'm going to take each of these factors, raise it to the third power. So a squared cubed, b cubed, divided by, same thing here, a cubed raised to negative 4, b raised to negative 4. And now I'm going to use the power rule. So 2 times 3 is 6. I get 8 to the 6. This right here is understood to be a 1. 1 times 3 is 3. It says b to the third, divided by 3 times negative 4 is negative 12. And then that's a 1 right here. 1 times negative 4 is negative 4. And so now I'm going to use the quotient rule. So remember what I used here was the power rule. And I'm going to use the quotient rule. And so we divide like bases, subtract exponents. So that's 8 to the 6, subtract negative 12. Times b to the third, subtract negative 4. And so remember, 6 subtract negative 12 means 6 plus the opposite, which is positive 12. So 6 plus 12 is 18. And then that's b, subtract negative 4 is 3 subtract negative 4 is 3 plus a positive 4. So that's going to be 7. No negative exponents, so you're done. So the answer, that's the answer number 7. So number 7, the answer is a to the 18th, b to the 7th power. All right, number 8, you have, x, y, negative 7th divided by x squared, y to the 4th, cubed. So again, I'm going to use the power product first. So that's going to be x to the 7th, that's negative 7, y to negative 7 divided by, and then that's going to be x squared to the third, y to the 4th to the third. Now I'm going to use the power rule. So that's, remember, that's a 1, that's a 1. So 1 times negative 7 is negative 7. So that's going to be x to the negative 7, y to negative 7, divided by 2 times 3 is 6 here. So that's x to the 6, y to the 12. All right, so now I'm going to use the quotient rule. So it'll be x to the negative 7, subtract 6, y to the negative 7, subtract 12. All right, so now negative 7 subtract 6 is a negative 13. Negative 7 subtract 12 is a negative 19. All right, now remember, don't leave your answer. Like, see here, you don't want your answers with negative exponents, so that's why you stopped here. But here you can't stop because those exponents are negative. So you got to use the negative exponent rule. So remember, x to the negative 13 means 1 over x to the 13th power. Y to the negative 19th means 1 over y to the 19th power. Do not leave your answer like this because you're not going to get full credit. You got to write as one fraction. 1 times 1 is 1, and then x to the 13th times x to the 9th times y to the 19th is x to the 13th, y to the 19th. All right, so that's answer number 8. So number 8, you have 1 divided by x to the 13th, y to the 19th. Okay, number 9. Number 9, you have this. Number 9, you have negative 24, m to the 7th, n to the negative 5th, divided by 6, m to the negative 3rd, n to the negative 2nd. All right, so that kind of looks like number 9, looks just like number 1. All right, so let's reduce. Now, there are no parentheses. No parentheses, so you're not using the power rule. You're not using the power of a product rule, the power of a quotient rule. You're just going to use the quotient rule. And then you're going to use the fact that you know how to reduce the coefficients based on what you've learned in previous courses. So let's do the coefficients first. 6 and negative 24, the greatest common factor of those is 6. So 6 divided by 6 is 1. 6 divided into negative 24 is a negative 4. So negative 4 divided by 1 is a negative 4. So far I have this. I have negative 4 times, all right, now let's use the quotient rule with the m's. Divide like bases, subtract exponents. So that would be m to the 7, subtract negative 3, times n to the negative 5, subtract negative 2. So remember, it's always subtract. 7 subtract negative 3. Negative 5 subtract negative 2. Now 7 subtract negative 3, remember, we keep talking about that. You got to remember this. Change the subtraction to addition, so you got to add the opposite. So it becomes 7 plus, and the opposite of a negative 3 is a positive 3, so that is 10. So this becomes negative 4 times the m to the 10th power. Here, negative 5 subtract negative 2, that becomes negative 5 plus a positive 2, and so that's negative 3. So then that becomes n to the negative 3rd power. This is the only one that has a negative exponent, so you got to rewrite this part. Everything else stays the same. So that's negative 4 m to the 10th times 1 over n to the 3rd. And then you write it as one fraction. So that's negative 4 m to the 10th divided by n to the 3rd. All right, so that's number 9. So number 9, your answer is negative 4 m to the 10th divided by n to the 3rd. Okay, number 10 looks like this. Okay, so that's number 10. You have, in the numerator, you have negative 4 x squared y to the negative 5th, all raised to the negative 3rd power. And then x y squared, all raised to the negative 2nd power. Now, the only thing that's going to cause you an issue here is this coefficient right here, because that coefficient being raised to negative power. If this was a positive power, it would be easy to deal with, but it's not. So just be a little bit careful with the coefficient. Everything else should be fine. All right, so we're going to use the power of a product here. So just be careful. This is what you're saying. You're saying negative 4 raised to the negative 3rd power times x squared raised to the negative 3rd power. Power raised to power. You're just taking each of these and raising to the negative 3rd power. Times y to the negative 5th raised to the negative 3rd power. All divided by, same thing here, x to the negative 2nd power. And then y squared raised to the negative 2nd power. All right, now, here's how you deal with this. So remember, if you look at this from here, this right here is going to be a 1. Okay, so now you use a power rule. 1 times negative 2 is negative 2. So in this denominator right here, when you look at this first, you have x to the negative 2. Now the reason why I did that one first was so I can use that idea with this. So remember, negative 4 right here, that's really 4 to the negative 1 power. And now remember, that's negative 4. So basically, you're actually saying this. All right, so that's negative 4 to that 1 power, and then 1 times negative 3 is negative 3. So this is what you're saying. You're saying negative 4 to the negative 3rd power. Okay. All right, and then that'll be easier to deal with. Here, 2 times negative 3 is negative 6, and then negative 5 times negative 3 is positive 15. Here, 2 times negative 2 is negative 4. Okay, now, here's how you would deal with this. See, here you're dividing like bases, so you use a quotient rule here and use a quotient rule here. Now, here's how you deal with this. So, notice that negative 4 is being raised to negative power, and it's located in the numerator. So remember, we talked about something like this before. If the exponent is negative in the numerator, you're going to bring it to the denominator. So basically, you're going to have this. You're going to have instead of saying negative 4 to negative 3rd, you're going to say it will be 1 over negative 4 to the positive 3rd. Okay, that's a positive 3. So 1 over, since in the numerator, so you're going to say 1 over negative 4 to the positive 3. And then the rest of this, you're going to say x to the negative 6, subtract a negative 2. And then I'm running out of room here. And it'll be y to the 15th, subtract a negative 4. All right, so I get 1 over, and then negative 4 to the 3rd power means negative 4 times negative 4 times negative 4. Negative 4 times a negative 4 is a positive 16, and a positive 16 times negative 4 is a negative 64. So it becomes negative 1 over 64 times x to the negative 2 subtract negative 6 subtract negative 2 is negative 6 plus 2, so that's negative 4. 15 subtract negative 4 is 15 plus 4, so that's 19. And again, this is a negative exponent, so you're going to write it as negative 1 over 64 times 1 over x to the 4th times y to the 19th. and write as one fraction out. So the answer is going to be negative 1 times y to the 19th is negative y to the 19th. 64 x to the 4th times 1 is 64 x to the 4th. All right, so that one was a little bit more challenging, number 10. But remember, you want to write all these as one fraction. So it's a negative y to the 19th divided by 64 x to the 4th. Okay, so that's going to take care of worksheet 12.2, part C.